Ever pondered the sum of all natural numbers? Does it even have a sum, or is it just infinity? This might seem like a riddle, but it's a legitimate question in the realm of mathematics. Infinity, a concept that boggles the mind and challenges our understanding of reality. It's not a number in the traditional sense, but rather a symbol, a representation of an unbounded quantity. In mathematics, infinity plays a crucial role. It's a paradoxical character that often leads us into the realm of the seemingly impossible. But it's in these impossible places where some of the most fascinating aspects of mathematics come to life. And one of these fascinating aspects is the idea of summing all natural numbers. Yes, you heard it right. Adding all natural numbers together, 1 plus 2 plus 3 plus 4, and so on, forever. But wait, wouldn't that just be infinity? After all, we're adding an infinite number of increasingly larger numbers. It seems logical to assume that the sum is infinite. But here's where the enigma of infinity throws us a curveball. Enter the Ramanujan's paradox. Named after the Indian mathematician Srinivasa Ramanujan, this paradox proposes a mind-bending solution to the problem of summing all natural numbers. According to Ramanujan, the sum of all natural numbers is not infinity. On the contrary, it's a very finite and rather unexpected number, -1/12. Yes, you heard it right, -1/12. Sounds impossible, doesn't it? How can adding up all natural numbers, which are all positive, result in a negative number? And not just any negative number, but -1/12. It seems to defy logic, reason, and everything we know about mathematics. But that's the beauty of infinity. It's a concept that challenges us, that pushes the boundaries of our understanding. It's a concept that leads to paradoxes and impossibilities. And it's these paradoxes and impossibilities that make mathematics so fascinating, so endlessly intriguing. So, does the sum of all natural numbers really equal to -1/12? Let's delve deeper. Enter Srinivasa Ramanujan, the mathematical prodigy from India. Born in the late 19th century, Ramanujan was a self-taught mathematician who made substantial contributions to mathematical analysis, number theory, and continued fractions. Despite his lack of formal education and training, Ramanujan's genius was recognized by the mathematical community. He was known for his unique approach to solving mathematical problems. Rather than following traditional methods, Ramanujan often relied on his intuition and novel techniques. His work was characterized by a blend of creativity and rigorous mathematical reasoning, which allowed him to produce results that were both innovative and profound. Ramanujan's extraordinary talent and passion for mathematics led him to question many established theories and norms. One such endeavor led him to present an idea that would challenge the very foundations of mathematics. Ramanujan, a man of little formal education, dared to question the conventional wisdom and presented a revolutionary idea. Opening, how can an infinite series of positive numbers possibly add up to a negative fraction? Sounds absurd, right? Well, welcome to the intriguing world of Ramanujan's paradox. Now let's try to simplify this enigma. In conventional mathematics, if you start adding all natural numbers together, 1, 2, 3, 4, and so on, the sum logically should be infinite. After all, you're adding an infinite number of positive numbers. But Ramanujan's paradox tells us a different story. According to this paradox, the sum of all natural numbers, oddly enough, equals -1/12. Yes, you heard it right, -1/12. You might be wondering how this could be possible. The key lies in understanding that this paradox is not about the sum in the way we typically understand it. In fact, this paradox is a result of a particular method of summation of divergent series. Divergent series are infinite series whose terms do not approach zero. In other words, these series don't have a traditional sum. They just keep on growing to infinity. However, mathematicians over the years have developed ways to assign values to these divergent series. And one such method is what Ramanujan used. Now let's take a step back and think about the paradox again. The paradox is not saying that the sum of all natural numbers is literally -1/12. It's saying that if we assign a value to the divergent series of natural numbers using Ramanujan's method of summation, that value would be negative 1/12. This is what makes the paradox so fascinating and counterintuitive. It breaks the conventional rules of mathematics and takes us into the realm of abstract mathematical concepts. And yet, it is precisely this kind of out-of-the-box thinking that has helped push the boundaries of mathematical knowledge. Closing. And there you have it, a seemingly impossible mathematical paradox, made possible by Ramanujan's genius. Scene script. Ready to dive into the math behind this paradox? Hold on to your hats. It's going to be a thrilling ride. Let's start with understanding the zeta function. Named after the Greek letter zeta, this function is a key player in the field of number theory. It's a function of a complex variable, which means it takes complex numbers as input and spits out complex numbers as output. But don't worry, we won't be delving into complex numbers. For our purpose, we will focus on the zeta function when the input is a real number, which is a number we are all familiar with. The zeta function at 2, for example, sums the reciprocals of all natural numbers, each raised to the power of 2. This sum surprisingly converges to a finite value, which is pi squared divided by 6. Yes, you heard it right, the same pi, that's the ratio of a circle's circumference to its diameter. Now, what happens if we take the zeta function at -1? Here comes the twist. Instead of summing reciprocals, it sums the natural numbers themselves. But wait, isn't that what we've been talking about? The sum of all natural numbers? Exactly. So, how did Ramanujan use this to arrive at his paradoxical result? He used a process called analytic continuation of the zeta function. This is a method in complex analysis that extends the domain of a given function to include points where it may not be initially defined. Through this process, Ramanujan was able to extend the zeta function to negative numbers, including -1. This is where the magic happens. The zeta function at -1, which sums all natural numbers, does not converge in the traditional sense. It diverges to infinity. However, through a process called Ramanujan summation, he was able to assign a finite value to this divergent series. And guess what value he found? Negative 1/12. Yes, you heard it right. The sum of all natural numbers, according to Ramanujan's method, is negative 1/12. This result is, of course, counterintuitive and paradoxical. It goes against our basic understanding of addition. Yet, it is a result that has found applications in many areas of physics, particularly in string theory and quantum field theory. Remember, this doesn't mean that infinity equals negative 1/12 in the traditional sense. It's a result of a specific mathematical method applied to a particular series of numbers. It's an example of how mathematics can sometimes lead us to strange and fascinating places. And that, folks, is the magic of mathematics. An infinite series of positive numbers can indeed sum to negative 1/12. So what does this paradox tell us about the nature of mathematics and reality? Well, in its essence, Ramanujan's paradox unravels the perplexing fabric of mathematical logic and the very concept of infinity. It's like an enigmatic riddle, challenging our understanding of the universe and its fundamental principles. You see, the paradox is not about numbers adding up or not. It's about how we perceive and interpret mathematical rules, especially when it comes to infinity. This paradox forces us to rethink our preconceived notions about arithmetic and the way we have been taught to understand it. Moreover, it highlights the power of mathematical abstraction. Infinity, after all, is not a number but a concept. It's not something we can measure or quantify, but a notion that transcends our everyday comprehension. And yet, in mathematics, we use it as if it were a tangible entity, a tool to solve problems and make sense of complex phenomena. But perhaps the most intriguing aspect of this paradox is its philosophical implications. If a series of natural numbers can sum up to a negative fraction, what does that say about our reality? Does it suggest that our universe too might be filled with paradoxes and contradictions that we are yet to uncover? Could there be more to reality than what meets the eye? Ramanujan's paradox, therefore, is more than a mathematical enigma. It's a testament to the beauty, complexity, and mystery of the world we live in. It reminds us that mathematics is not just a set of rigid rules and formulas, but a dynamic and evolving field of study, constantly pushing the boundaries of human understanding. With this paradox, Ramanujan invites us to look beyond the obvious, to question the accepted, and to embrace the seemingly impossible. He urges us to delve deeper into the realms of knowledge, to challenge our perspectives, and to continue our quest for truth, however elusive it might be. As Ramanujan showed us, sometimes, to find the truth, we must dare to venture into the realm of the absurd.